Hey guys, I'm Miuccamatics and welcome back to my YouTube channel Miuccamatics. Paths and circuits. Definition of a path. Let G be a directed graph with m edges, that is E1, E2 up till En. A path in G is a sequence of edges EI1, EI2 going up till EIK, where EI1, EI2, EIK belong to the set 1, 2 up till N. And such that the terminal vertex of Eij is equal to the initial vertex of Eij plus 1, where j takes the values 1 up till k minus 1. So since it's a sequence, it tries to tell us that there is no break basically. And here, the Ei's basically take the values 1, 2 and up till m. We write it in this way because it need not follow the same order. It need not be E1, E2, E3 and so on. It can follow any order. Hence we write in the form of EIs, where EIs take the values 1, 2 up till m. The second condition is the terminal vertex of the previous edge is same as the initial vertex of the next edge. Here j takes the values 1 till k minus 1 because it starts with EI1. So EI1 being the terminal vertex of EI1 being the initial vertex of EI2, that is EI1 plus 1, and it continues that way EI2, EI3, EI3, EI4 up till k minus 1, that is the terminal vertex of EIK minus 1 is same as the initial vertex of EIK because EIK is the last edge. In order to be a circuit, there is an additional condition. Further, if the terminal vertex of EIK is equal to the initial vertex of EI1, then the path is called a circuit. Basically a path which returns back to its initial vertex. That is, the terminal vertex coincides with the initial vertex. So basically it forms a circuit. Here are examples. This is a given graph. E6, E3, E4, E5, E3 is a path. You notice there is no break. It doesn't go from here and goes here. Basically it's a continuous chain sort of. So it's a sequence of edges where the terminal vertex of the first edge is same as the initial vertex of the next, and that continues. E3, E4, E5, E3, E4, E5. So you notice the first condition is satisfied, the terminal vertex is equal to the initial vertex, and also the terminal vertex of the last edge is same as the initial vertex of the first. E2, E1, E3, E4, E5, E3 is a circuit. As you notice, we return back to the first vertex. E4 is a path. Basically, this is the simplest path possible. E2, E1, E6. E2, E1, E6 is not the path, as if you notice, the direction is opposite. Hence, the terminal vertex of E1 is not the initial vertex of E6. Hence, this won't be a path. Now the definition I mentioned earlier was for a directed graph. We can also define a path for an undirected graph. Path in an undirected graph, let G be an undirected graph with m edges, E1, E2 up till Em. A path in G is a sequence of edges EI1, EI2 up till EIK, where EI1, EI2 up till EIK takes the values 1, 2 up till M, and such that Eij and Eij plus 1 are adjacent edges. Further, if EIK and EI1 are adjacent, then the path is called a circuit. If you notice, it's the same definition as the previous, except since it's an undirected graph, the direction is not important. So we don't need to mention terminal and initial. So if we just mention the two edges are adjacent, well, it's sufficient in an undirected graph. Here is an example. E4, E5, E2 is a path. Now E5, E1, E2, E5, E4, E3 is a circuit. as if you notice we return back to the vertex V3. Note, a path in a simple linear graph, a simple graph is also called a linear graph, can also be defined in terms of vertices. In an undirected graph, a sequence of vertices vi1, vi2 up till vik forms a path if vij and vij plus 1 are adjacent. So it's the same definition but in terms of vertices. J takes the values 1 up till k minus 1, same as in the previous. So basically if you notice, this would be an edge and two vertices will form an edge in the previous definition. How would you define a circuit? Basically further, if vi1 and vik are the same vertex, then the path is called a circuit. This is an example. v1, v2, v3, v5, v2, v4 is a path. If you notice, the vertices are adjacent to each other. V4, V2, V3, V5, V4 is a circuit. As you notice, we begin at the vertex V4 and we end at the vertex V4. So EI1 becomes equal to EIK. Now for a directed graph. In a directed graph, a sequence of vertices vi1, vi2, vik forms a path if vij is adjacent to vij plus 1. So basically the order is important. So we need to say the previous vertex is adjacent or basically to vij plus 1. Where j takes the values 1 up till k minus 1. And if vi1 equal to vik, then the path is a circuit. This is an example. Basically it starts from v1, v1, v4, v2, v6, v5, v2, v6 and v4 is a path. A question, is v1, v2, v5, v3 a path? v1, v2, v5, v3. It's not a path as v2. If you notice, v2 is not adjacent to v5. It is adjacent from actually. Now a simple path and a circuit. A circuit or a path is said to be simple if no edge in it is repeated. If you see the above example, it is not a simple path as v2 to v6 is repeated. So here if you notice, it's repeated twice. So the edge v2, v6 is repeated. Note, a path ei1, ei2 up till eik is said to meet or pass through all the vertices incident with ei1 up till eik. Because if it's a path, it has to pass through the vertices. Definition of elementary path and a circuit. A path or a circuit is said to be elementary if it does not meet the same vertex twice, except possibly for the first, that is the initial, and the last, that is the terminal vertex. This condition is true only in case of a circuit, as the basic definition of a circuit is the initial and terminal vertex coincide. Else for a path, just this condition that it does not meet the same vertex twice. The above example is not elementary as it's not even simple. The same example. Every elementary path has to be simple. So that's because if a vertex does not repeat, if the vertex does not repeat, definitely an edge will not be repeated. Hence every elementary path will be a simple path, also in terms of circuit.